best abstract lightning talk goes to Dr. Ella Reid.
The problem with pancreatic cancer is that unlike other cancers like breast cancer, colon cancer and prostate cancer, we don't have a screening program, we can't detect it early, and it's simply because we don't know how the disease actually begins. With other cancers you have quite specific symptoms. With pancreatic cancer it's either completely asymptomatic, so we don't get any symptoms at all, or they're very vague, so things like fatigue, weight loss, tiredness, loss of appetite, things that you kind of associate with other things like being stressed. And also we can't just go in and take a biopsy as well, because by the time you get to that point you have very late stage disease, so we can't detect it early because we don't know how it begins. So our research focuses on these very early stages of pancreatic cancer, understanding how it starts, and therefore can we detect it earlier and can we stop it earlier before it progresses into late stage disease. We look at how the cells actually talk to each other, so like I'm talking to you now and you talk to me, I give you signals and you can give me signals on how to behave. That's what cells do as well, and in particular I look at how these cancer cells talk to the immune cells. What immune cells normally do is they eat cancer cells because they are bad for us. However, these cancer cells are now actually able to talk to these immune cells and say, don't eat me, I'm perfectly fine, move on to somebody else. So that's what we've discovered, and it's a potential way of stopping the disease early before it progresses into late stage disease. The discovery of the signal of the cancer cell talking to the immune cell with the don't eat me signal, that was a real groundbreaking moment for us as a team, and now that's kind of changed what we're doing, the direction of our research, and it's opened up new doors. And what's exciting is that people haven't looked at this before. This could hopefully give us a new therapeutic for pancreatic cancer, because pancreatic cancer doesn't respond to therapies targeting the immune system. This could change that, make the cancer sensitive to the immune response. What we need to do now is we need to go into the lab and we need to do some functional assays to really prove what we're seeing is true. And if that is the case, then we could develop a novel therapeutic and then test that, and then who knows where it can go. It's very exciting. I did a medical pharmacology degree at Cardiff, and then whilst I was there, one of my friends got cancer. So that kind of spurred me into cancer research. I think like a lot of people, you have a personal experience. I think what we can lose sight on is because we're not kind of medical doctors, we don't see patients, so we can lose sight of why we're doing what we're doing, because we're in a lab behind closed doors. Having the patient in mind is really key. I try and do like patient engagement just to really understand the value of what we're doing, and to see the effect of it as well is really rewarding, because it's hard, like it's a hard job. Things go wrong all the time, but having that patient in mind is what gets us through the day.